Hello and welcome to my Digi presentation. Today I'm going to be explaining to you some of the processes that lead to different geological formations. This Digi explanation will focus on sedimentary rocks and Steno's principles of stratigraphy. But before I get started, let's recap what a sedimentary rock is. A sedimentary rock is one of the three main rock groups, along with igneous and metamorphic rocks, and it is formed in four main ways. Firstly, it can be formed by the deposition of weathered remains of other rocks known as clastic sedimentary rocks. They can also be formed by the accumulation and consolidation of sediments, by the deposition of the results of biogenic activity, and finally by the precipitation of minerals from solution. These rocks are deposited over long geological timescales of hundreds of thousands and millions of years. Now that we've got that covered, today we will discover how the principles of sandwich making can be applied to our study of earth science. You may never have seen this sandwich before, but how do you think it was made? Like any other sandwich, of course, with a slice of bread on the plate, followed by the filling and another slice. We know this because we've all made similar sandwiches before. The process you have gone through in the past to make a sandwich is the same as the process we use today. In geology, this is similar to the principle of uniformitarianism, the idea that natural processes that are operating today have operated in the same way in the past. This concept forms the basis of Steno's principles. So let's investigate what they are. On this sandwich, which layer is the first or the oldest, and how do you know? The piece of bread on the bottom, as it was placed there first. The same as the bottom book in this pile. This idea summarizes Steno's first principle, the principle of superposition. That is, that younger layers of rock sit atop older layers. This can be seen when you see layers of rocks on top of each other at a cliff face. So what about this toothpick? Was the sandwich made first and the toothpick stuck in, or was each layer added to an existing toothpick one by one? The toothpick helps to represent the principle of cross-cutting relationships. When layers are cut through by another object, the cut is younger than what it cuts through. An example of this would be an igneous intrusion, cutting through sedimentary layers. Okay, so imagine you're sitting in science class. Alex sits on one side of the room with one half of the sandwich, and Jenny has the other. Would you assume that they brought identical sandwiches from home, or that they had cut it in class? As they have identical sandwiches with the same order of fillings and thickness, you would assume they cut it here at school. This leads us to our third principle, the principle of original lateral continuity. Layers of sediment, now truncated, must have been deposited as laterally continuous layers. This could occur through a fault and movement in the Earth's surface. Finally, there is one last principle. If you found this sandwich and it looked like this, folded in half, do you think this happened before, during, or after it was made? This leads us to our final principle, that of original horizontality. Layers, now inclined, must have been deposited as nearly horizontal layers. This sort of folding could occur when compression in the Earth's crust causes layers to fold. So the laws of sandwich making help us to understand the principles of stratigraphy and how different sedimentary features have been created. To recap, there are four laws. They are the principle of superposition, that younger layers sit atop older layers, the principle of cross-cutting relationships. When layers are cut through by another object, the cut is younger than which it cuts through. Original lateral continuity. Layers of sediment now truncated or cut must have been deposited as laterally continuous layers. And original horizontality. Layers now inclined must have been deposited as nearly continuous horizontal layers.